Well, now we're doing the review for section 10.2, and we have to solve this system using matrices and row operations. So first of all, let's construct an augmented matrix. Okay, so I replace x, the coefficient on x is 1. The coefficient on y is positive 1, and the result of that sum is 8. The coefficient on x here is 1. The coefficient on y is negative 1. And the difference is 4. So here is our augmented matrix. And we're going to solve this using row operations. So if we can get a 0 in this position and a 1 in this position, we can go ahead and identify the values of x and y that are the solutions. So we aren't going to change the first row. That's sacred. But to get a 0 in this position, we'll take row 2 and, and from it we will subtract row 1, and that will replace row 2. That's the notation. Row 2 minus row 1 will replace row 2. So 1 minus 1 is 0, and negative 1 minus 1 is going to be negative 2. Negative 8, or 4 minus 8. I beg your pardon, and let me do what I'm, rather than talk about it. Here's what we're doing. We're taking row 2, 1 minus 1 and 4, and from it we're going to subtract row 1. So that's minus 1, and minus 8. And so we get a 0, a negative 2, and a negative 4. So there's the negative 4. Okay, now we want a 1 in this position. So row 1 doesn't change. The 0 doesn't change, but we'll multiply negative 1/2 times row 2 will replace row 2. So that gives us a 1 and a 2. Well, now what the implication is that this is the coefficient on y, so this implies that y equals 2. 1 times y equals y, and y equals 2. And for this row, we have x plus y equals 8. But y is 2, so let me do it here. X plus 2 equals 8. So solving for x, we get x equals 6. So now the ordered pair that solves this thing is x, y, which is 6, 2, and we're done. We use row operations and matrices to solve.